So can you start by telling me what the climate shift index is?
Sure. So we developed the Climate Shift Index last year based on several years of research done by us at Climate Central and others around the world. And what it does is it brings together a whole bunch of different techniques to try to separate the normal day-to-day variability in weather from this long-term climate change signal. And so what the CSI, the Climate Shift Index, allows us to do is to be able to say, for any given day's temperature anywhere in the world, how much more or less likely that temperature is due to climate change.
And how do you do that? That seems really hard to pin down.
Yeah, so we're very lucky that we have a lot of great data to draw on and a lot of great, decades of science to build on. So we use local trends, which is a really important way for understanding how any given place on the planet responds to the global warming signal. So that's one pathway. The other thing we use are climate models. And the great thing about climate models is you basically have the Earth in a computer. And so you can run the test of what would the Earth look like if we hadn't put all of this extra carbon dioxide in it. And so it gives us this very direct comparison of the world that we have versus a world that we could have had if we hadn't put a whole bunch of CO2 into the atmosphere.
And this may be like a philosophical question, but what is normal anymore? So when you say the normal variability, normals are always changing every 30 years. So it seems like it can't be a very exact science, but you guys have really nailed down this to an exact science.
Yeah. So by normal, what we're talking about, normal day-to-day weather, we're sort of thinking about like how within whatever climate you have, right? Today's climate that has a whole bunch of greenhouse gases or an earlier one, you have this idea that at a location, how likely are you to have a cold day versus a warm day, and what's sort of an average day? And we know how those distributions have shifted due to climate change. That's really what we're trying to diagnose with this system is what is that distribution, what is the frequency of temperature in today's climate? And what would that frequency of temperature look like if we were to remove the CO2 signal?
Let's talk about the heat that's been going on out west. Can you have been able to attribute that to climate change and CO2 in the atmosphere? Can you talk about what that heat is and how likely it is that this is caused by climate change?
So the heat that we saw last week in the West was really remarkable, right? We were seeing places from Baja California all the way up to British Columbia that were 8, 10, 15 degrees, even more above normal. And what we were able to do with our Climate Shift Index tool was to really diagnose how much climate change influenced those temperatures. And we were seeing throughout last week places, especially along the Sierra Nevadas, places like Yosemite National Park, that where those temperatures were more than 5 times more likely due to climate change. So it's a very strong signal. It's a very high degree of attributability that suggests that climate change was really making those temperatures much, much more likely than they would have been if we didn't have all of this extra CO2 in the atmosphere.
Okay, so then you mentioned Yosemite. They had to close this past week because of flooding. So how can you attribute flooding then back to climate change as well?
So that's a really fantastic question. So we're focusing very clearly on the temperatures, on the heat, but of course that's part of it, right? If it hadn't been warm, things wouldn't have melted. But then you have to ask, okay, well, what was, there was so much snowpack to melt. That's a big part of the story, right? 200, 300% more snow than normal. And that probably has a climate signal as well. This isn't part of our analysis, and I expect there will be some scientific studies that come out of that. But, a warmer planet, you can put more water vapor into the atmosphere. And so the big atmospheric river events from this spring probably had a climate fingerprint on them as well. So we're seeing two things adding together. Climate change made those big snows more likely, and then climate change made this early intense melt more likely.
All right, what about overnight lows? Everybody talks about afternoon highs and the impact of really hot temperatures in the afternoon. Can you touch briefly upon what's going on with our overnight lows and the dangers in those coming up as well?
So when we look around the country and around the world through the lens of our climate shift index tool, one of the things that really stands out is how much stronger the climate change signal is at night. And that was very much at play in the event last week in the West, where, we were seeing, unusually warm high temperatures. We were seeing also unusually warm low temperatures. So things weren't refreezing overnight. And that those overnight low temperatures had an even stronger climate change signal. It was a much more robust signal. And that's a big part of the story. And we really see that all over the world. We see that, in summer heat, especially in the Southeast, any place that's really humid will often have this much stronger climate signal at night.
All right. Can you tell me about what you guys have going on your website? Because you have some really cool tools that you can play with, and you don't have to be a scientist to play with these and understand how they work.
Yeah, so we've put a few tools out, some different ways that you can look at the climate shift index. So we have our US focused tool where you can look at temperature, you can look at the departure from normal, what we call the anomaly, and then you can look at how that translates into our climate shift index numbers. We also have a global tool, which is that's the one I really like. It's a really nice interactive map where you can see the whole world laid out before you. Can you really see where the heat is on the planet and where things are unusual right now?
And when we talk to you guys at Climate Central, we always think past weather information, but you're really looking at some forecasted weather information this summer and attributing heat to climate change, correct? It's going to be a big push.
Yeah, and that's one of the things that I'm really excited about our system. They're fantastic scientists all over the world. Our colleagues at the World Weather Attribution Group are just doing an amazing job at taking these events and diagnosing them after they've occurred. And they can get, really specific and really get down into the detailed meteorology behind a particular climate-driven event. What we've tried to do is say, well, what can we do as almost like a screening tool where we can do it every day, or we can even do it in forecasts. So the event last week, we started picking it up the week before, and we started doing some of our analyses, early last week, and we're able to really say that this event that was coming had a detectable climate fingerprint that we could really quantify and let people know that climate change was active in California last week.
And speaking of quantifying, everybody wants to talk about the hurricane season and how to attribute big events when it comes to hurricanes or atmospheric rivers to climate change. Do you think that we'll get to that point where we can quantify that as well?
We're already there. Scientists know how to do that. The challenge is that you usually have to do that right now with very detailed weather models. And so you can only do it after the event. But like Hurricane Ida last year, some colleagues at Stony Brook University were able to get a study out, within a day or two of landfall of Ida that showed how climate change boosted the amount of rain coming. We're working on some ways where you can try to relate ocean temperature to the strength of some of these ocean-driven storms, because that's a lot of the moisture, a lot of the energy coming into these big atmospheric river storms or hurricanes is really stored in the ocean. And there's such a strong climate signal in the ocean that we think that's a pathway where we can do some of these more, operational kinds of statements.
Hey, thank you so much for watching. While you're here, check out some other videos you just may like.